Well, hi, and welcome back to Mrs. Cox's math class. And today I'm working with grade 8, review day 5. So this is the beginning of the year, review day 5. And this one is, again, as we keep working on it, we keep working on some of the tougher stuff in the 7th grade math concepts. And this one is all about finding the area of composite figures and then finding surface area. And so this one was really tough. But again, it's going to get those formulas at the beginning of the book and the beginning of their notebook. So hopefully they're going to be all together, easier for them to find. And so we'll take a look at what those actually were and how to find those and get more math. So again, the beginning of my year, it's always the Get More Math is what I use. So what I did is I just compiled all of the important skills that they did in 7th grade, and that made up my review. So this is beginning of the year review day 5. And it's determining area of composite figures and determining surface area. So I'll assign that to my summer school class. And so now that's been assigned, and I'll log in as my student account, and we'll see here it is. And so the first one is the surface area, and this is skill code 1062044. And the other one is composite, finding the area of composite figures, and this is 1062027. So those are the two skills that I'm focusing on for this lesson. They only have to get 4 points because I don't want them to spend a tremendous amount of time. These take a long time, and I just want that reminder. So after they have 4 points, it will switch automatically to mixed review. And if they're stuck, they can switch it to mixed review in class, and then they can actually come to tutoring as well. So one of the things I try to teach my students to do is, if I'm helping another student, the one cool thing about Get More Math is I'll go ahead and click on this. Say I'm having a problem with this. I click on the hand. As I come over here and I look at my classes, so as a teacher, I would have this open all the time. So let me find that class, summer school, I think it's this one. And there I am, and there's my hand up. And so if I'm working with another student and this student can't, I can't get to the student to help yet, my recommendation is for them to switch over to mixed review, work as much as they can on mixed review, and then when I come back, they can put their beginning of the year review back up and go, okay, this is the problem I'm struggling with. So it allows them to keep working, still getting their 25 points for the day, so that they're not just sitting there doing nothing while they wait for me to come over and help them. One of the other things that I also do in my classes, I very much encourage students to get up and help other students in the classroom. So there's other students who, once they're done with the assignment and they feel like it's pretty easy, they get up and they help other students with the math. By the time they're in 8th grade, they're getting really, really good at doing that. It takes me half of 7th grade to encourage them to get up and do that. By the end of 7th grade, they're getting pretty good at it. So when I introduce it again at the beginning of 8th grade, they absolutely want to get up and help. And so, that's really nice. And a lot of kids, they enjoy getting help from their peers. So I do that a lot in my classroom. And so now I'll actually just show you the video that the students watched the night before. So they watch this the night before, they come into class, we talk about it, we review, we work a couple problems, and then they go straight to work. Hi, so we are ready for Tuesday, beginning of the year review day 5. And this one is all about now taking the area of shapes and looking a little deeper at that. So, okay, so I'm going to share my screen. And this is where we are. So it's beginning of the review, day 5. This is area of complex shapes, surface area, and lateral surface area. So you can see that this is the stuff that you hated from last year, and it is back. Okay, so as we start to work on these, we want to find this area, and we know the shape right here is a rectangle. And so what we want to do is we want to come up with a plan, all right? So I know in order to get this shaded, all we want is this part right here. We don't want this right here. So I have to come up with a plan. Well, I see that if I took the area of this big rectangle and then I subtracted the area of the little rectangle, I'm going to get the area of just the shaded part. So I'm going to come up with my plan. I'm going to take the area of the big rectangle, and I always start with my plan, and then I'm going to subtract the area of the little rectangle. And that's going to give me my total area. And that's what I want. I want the area that they're actually looking for. And so I just want that area of that shaded part. So that's the first thing I do. I come up with a plan. Always, my first step, I come up with a plan. The next thing I do is I substitute my formulas to help me figure out the plan. The formula for the area of a rectangle is base times height. And then again, it's another rectangle, so the formula for the area of a rectangle is base times height. So the first step is always the plan. Always. So I always do the plan first. Then I go to formulas. Then the last thing I do is I substitute and solve. Okay, so that's what I'm going to do now. So I'm going to take the larger rectangle, and the shape is 45 times the height is 14. On the smaller one, it's 13 times 9. And then I just do the math. Well, I know 45 times 10 is 450. So I'm going to have 450 plus 45 times 4. So 4 times 5 is 20. I carry the 2. And 4 times 4 is 16, 17, 18. And then I'm just going to add these two together. So I get 0, 8, and 5 is 13. Carry the 1. And then 5, 6. And then here I can just multiply. It's going to be 27. This will be 7. Carry the 2. And that's 9, 10, 11. And then I'm just going to subtract, and that's going to give me my answer. Well, I can't take 7 from 3, so I have to borrow. And 10 minus 7 is 3. And 2 minus 1 is 1. And 6 minus 1 is 5. So that I know the area of just the shaded region is 513. And since it doesn't tell me what unit measure it is, I just go with units squared. Okay? So I'm going to come over here, I'm going to do that exact same thing. So this one's a little bit different. So instead of removing a shape, I have all these extra shapes. So the first thing I'm going to do is I'm going to draw this on my paper, and then I'm going to draw the other lines in so I can see all those shapes. And I see I have 3 shapes, right? So here's shape number 1, here's shape number 2, and here's shape number 3. And I know that if I just take all of these shapes and I just add them together, I'm going to get the total shape. So I'm going to take the area of shape number 1 and the area of shape number 2 and the area of shape number 3. And I know that if I just add them all together, I'm going to get that total shaded area. And that's what I want. Okay, so I want that total shaded area. And that's how I'm going to find it. So that's my first part, is I come up with a plan. So here's my plan. The second step is I'm going to put in my formulas. Okay, so the shape number 1, this is a rectangle, and the formula for a rectangle is base times height. The second shape is right here. Well, it looks like a rectangle as well, and the formula for a rectangle is base times height. And this third shape right here, you should be able to recognize this as a quarter of a circle. So you could actually see this coming over here. And it's this piece right here that we want. And so that is 1/4 of a circle. So what we're going to do is we're going to take the formula for a circle, which is pi r squared, but we only want 1/4 of it. So I'm going to divide it by 4. And that's going to be the formula I need there. So I created my plan, I put in my formulas. The next step is I'm just going to put in the numbers now and solve. Well, in order to do that, I'm going to have to figure out what these measures are, right? So this is 22, so I know this measure all the way across here is 22. And I know that this is 8 here, so this is 8. I know that this is 6, okay? And if this is 6 and the whole thing is 14, then I know that this measure right here is 8, because 8 plus 6 is 14. So I know that this is also 8. And if the whole measure is 12, then this piece right here is 4. So the next thing I'm going to do is I'm just going to figure it out now. So now I know that this is 22 times 8. So it's 22 times 8. The next one is 6 times 8. And the last one is going to be 4 times 4 divided by 4. So I'm just going to go ahead and write that. This is going to be 3.14. And I know that I'd have 4 times 4. And I'm just going to get rid of those right now and do my division. So it's just 3.14 times 4. And that's going to get me what I need. And again, I just divided that extra one by the dividing by 4s. I just cross-canceled those to get rid of them. And then I just do the math. 8 times 2 is 16. Carry the 1. 8 times 2 is 16, plus 1 is 17. 6 times 8 is 48. And then 4 times 4 is 16. Carry the 1. And 4 plus 1 is 5. And I know I'm going to move my decimal 2 places. And 4 times 3 is 12. So then I'll place a decimal and placeholders here so I can add. And then I just add them all together. And when you're adding with decimals, you just place your decimal, make sure they're all lined up, and then you just add like normal. So this is a 6, this is a 5. And then we have 6 plus 8 is 14, 4 plus 2 is 6, carry the 1. 1 plus 7 is 8, plus 4 is 12, 2 plus 1 is 3. And I carry the 1, and 1 plus 1 is 2. And they do have a unit measure, so we have to use that. And so they want to round to the nearest tenth. So this would become 236 point, and then this will round to 6, and then meters squared, because all along we did meters times meters, meters times meters, meters times meters. All right, let's take a look at the next one. So we're going to look at problem number 5. So problem number 5, well, we start to get a little more complicated, but it's the same thing. They want the area of the shaded region. That's this area right here. That's all they want. They don't want this part right here, so we don't want this. So again, in order to figure this out, we're going to come up with a plan. And to do that, what we're going to do is we're going to take the area of the bigger shape. So we always start, whenever we're subtracting, we have to take the shape, the area of the larger shape, and that's a square. And then we're going to subtract the area of the circle. And when we do that, we're going to get that area of that shaded area. So that's what we want. Okay, so I just want the area of the shaded part, and that's how we're going to do it. So the first thing I do is I create a plan. And here's my plan. I'm going to take the area of the square, I'm going to subtract the area of the circle. That's going to give me that area of that shaded part here on the edges. The next thing I do is I put in my formulas. Well, for a square, it's base times height. And for a circle, it's pi r squared. So the second step is I always put in my formulas. Then the third step, I just substitute and solve. So my base times height is 5 times 5. And then here, it's 3.14. Now, in order to see this, what I want to do is I want to go ahead and draw a line right here. Let's go ahead and put this over here. I'm going to put this right here, and then I'm going to turn this. I'm going to turn this until it looks like that's about even, right? There we go. Okay, and then I want to make it the same measure. Okay, so there's my line right there, okay? Now, if I took this, and I know this is 5 centimeters, and I got to figure out what r is, right? And it isn't telling me, but I notice that as I come across here, this is still 5 centimeters all the way across, right? So if I keep bringing it down here, I notice that when I get to the center of my circle, it's also 5 centimeters. So I know that the diameter is 5 centimeters, and I've got to figure out what the radius is. And remember, the radius is half of that. So I just want to figure out what half of that is from here to here. Well, then I know that I'm just going to take 5 and divide it by 2. So 5 divided by 2, because I know that this is half of 5 and this is half of 5. And so 2 goes into 5 2 times, which is 4, 1. So I'll add a decimal, so I can add a 0. And 2 goes into 10 5 times, so that I know that this measure right here is 2.5. And that gives me the radius, which is what I need here. So I'll come back down here. It's 3.14 times 2.5 times 2.5. And this one will be 25. And I know that I'm going to have decimals here, so I'm going to go ahead and just write them in right now. And then I have to do this math. Well, 2.5 times 2.5 times 3.14. And again, I don't mind you using a calculator at this point, because again, we're starting to get to be larger numbers here. So I don't mind you using the calculator, just as what I'm going to do as well. So I'll get to the calculator, and it's 2.5 times 2.5 times 3.14. And that's going to be 19.625. So I'm going to need to add another 0 here as a placeholder. And I'm subtracting. So you just want to remember, we are subtracting, so we want to subtract here, okay? Whenever you add or subtract, you just line up your decimals and you add or subtract like normal. Make sure that you do not round until you're done doing the math. So do all the math first, round at the very end. Otherwise, you could end up with the wrong answer. So I can't take 5 from 0, so I need to borrow, but there's nothing there, and I need to borrow, there's nothing there. So I'm going to have to come all the way over here to borrow. And of course, this would become a 9 now, and this would become a 9, so I can take one of them, and this will become a 10. Okay, and then I end up with 10 minus 5, which is 5. and 9 minus 2, which is 7, and 9 minus 6, which is 3. And I can't take 9 from 4, so again, I'm going to have to borrow, and that becomes 14, and it becomes 5. So I know the area of the shaded region is 5 point, and then I have to round 375 to the nearest tenth. So I look here, and I'm going to round up. So it becomes 5.4, and then they did give us a unit of measure, centimeters squared. And that would be your answer there, okay? Okay, so for the next problem, you're going to need some notes, and it's on surface area. So we're going to start with surface area. This is the area of all the sides of a three-dimensional shape. So when we say we want surface area, we want you to add up all the area of all the sides of the three-dimensional shape and add them together. So I want you to start by using these steps, okay? First one, create a plan. Second, step number 2, write down the formulas needed. Number 3, substitute in the formulas and solve. So there's 3 steps, pretty easy, and we're going to go through each one of them, okay? So step number 1, we're going to create the plan. So here is my plan. All right, so I know, and I always usually do this exact same way, okay, so that I never mess up. So I always do it the same way. So the first thing I need is I need the area of the front and the back. And I know that there's a back right back here that's exactly this exact same size. So I know there's 2 of them. So the first thing I'm going to do is I'm going to take the area of the front and the back. So again, I want you to write out all of this formula here this first time. After that, I don't mind you using abbreviations, but right now you need to know what it is. Okay, so I'm going to take the area of the front and the back. Okay, and then I'm going to take the area of the left and the right. So here's one side right here, and I know the other side is right over here. So I'm going to take that area of the left and the right. And I always do it in this order, and I think when we do the next problem, you'll see why I do it in this order, okay? And then the last ones, I'm going to take the area of the top and the bottom. Okay? All right. And then what I'm going to do is I'm going to add them all up. And when I add them all up, I'm going to get that surface area. And so here's the bottom, and here's the top right here. And I know that these and these are the same, right? So I consider this one the front. This one would be the right? The left would be over here. This would be the back over here. And then this one's the top. And then the bottom would be right down here, right? And then the next thing I do is I put in my formulas, okay? So first is my plan, then is my formulas, and then the last one is I actually substitute the numbers and I solve, right? So I have my plan, my formulas, and then I'm going to solve. So actually I'll substitute and solve. And it's the exact same thing. It's just got a little more detail here. So now I want the formulas. Well, I have a front and a back. They're the exact same thing. And when I notice the shape is a rectangle, so I'm actually going to have 2 rectangles. So I'm going to do 2 times base times height, because there's 2 of them, okay? That's going to give me the formulas for the front and the back. Well, then the left and the right. And I notice it's a rectangle again. There's 2 of them. They're exactly the same. So it's, again, 2 times base times height. And then I have the top and the bottom, right? So, and it's a rectangle, and they're the same. So again, I'm going to have 2 of those. So 2 base times height, since they're rectangles. The last thing I do is I just substitute and start solving. So I'll go with the first one, front and back. So I have the front here, I have base times height, which is 8 times 6. So it's going to be 2 times 8 times 6. The next one, remember there's 2 of them, and it's the left and the right. Okay, so in order to get the base, it's the same as this, which is the same as this, which is the same as this. So it's going to be 7 times the height, which is here, which is the same as the height, which is here, which is the same as the height, which is here, which is 6. And then the last one's the top and the bottom. Well, there's 2 of them, so it's going to be 2 times base times height. Well, here's the base right here, and the base is the same as this. So that's 8. And then the height is right here. So here's the height, and that's 7. And then all we do now is we just continue to solve, okay? And then we'll add all these together. All right, so we have 8 times 6 is 48. 48 times 2, 8 times 2 is 16. Carry the 1. 2 times 4 is 8, plus 1 is 9. So that's 96. 7 times 6 is 42, and then times 2. 2 times 2 is 4. 2 times 4 is 8, so that becomes 84. The next one, 8 times 7 is 56. Then we multiply it by 2. 2 times 6 is 12. Carry the 1. 2 times 5 is 10, plus 1 is 11. And now all we're going to do is add all these together. So 6 plus 4 is 10, plus 2 is 2. And we'll carry the 1. 9 plus 1 is 10. 0 plus 8 is 8, plus 1 is 9, and I carry 1, and 1 plus 1 is 2. So that I know that the total surface area here is 292 inches squared. Okay? And that's how you do a surface area. So again, come up with the plan, put in the formulas, then substitute and solve. Okay? The last one is going to be the lateral surface area. Lateral surface area, this measures the area of all the sides except the bases of a three-dimensional shape, okay? So make sure that you write that down, because it's pretty important so that you understand when we're talking lateral surface area what we're actually talking about. So it's the measure of the area of all the sides except the bases of a three-dimensional shape. So the first thing you have to do is you have to determine the base so you can leave that out of the calculation. So that's the first thing you have to do, is which ones are the bases, because I don't want the bases in this calculation. Then create your plan, then write the formulas needed to solve, and then substitute and solve. So if we take a look at this, the lateral surface area, so here's what we need to do. We have to figure out what the base is. When they tell you that it's a triangular prism, they name the base in the name of the prism. So the base is the triangle, okay? So we do not want the triangles here. So we just want the other sides, all right? So we do not want, we would call this the front and the back, right? We don't want that one. So what we want is we want the left side and the right side. Well, here's the right side right here, right? And then the left one right over here, we know is the same because it's using this same piece, and it tells us that these two pieces have the same measure, okay? So we know that one's the same as well. So we're going to take the left and the right. So what we're going to do is we're going to take the area of the left and the right. And again, right now, I want you to go ahead and write these, write all of this down so that you have it in your notes. When you start to do the math, I don't mind later on when you're doing Get More Math that you just use letters here. That's fine. We only have a bottom because this is a triangular prism. We don't have a top. So then we're just going to do the area of the bottom. And so that's all we have to do. And the bottom is down here. And we'll get that in just a second. And we know that if we add them up, we're going to get the lateral surface area. So lateral surface area is used a lot in calculating how much surface area there is on a house. You know, like if you're going to paint it, or you're going to put siding on it, or whatever. Like I put siding on my house this summer, and that's what we did. We calculated the lateral surface area because you're certainly not going to put the siding on the bottom of the house. You're not going to put it on the top of the house. You're just going to put it on all the sides. So lateral surface area is used for a lot of things. If you're painting your house, to help you understand how much paint you're going to need, it's that lateral surface area. And nobody wants to buy more than they need of anything, right? Okay, so we're just gonna, so now we've got our plan, and now we have to do, so here's our plan right here. And then we're going to put in our formulas, and then we're going to substitute and solve. So it's always that three-step plan. We'll get this done for you. So the first thing, we're going to come up with the formulas. Well, let's look at the left and the right-hand side. Well, the shape is a rectangle, okay? And we know they're the same, so we're going to have two of them. And the formula for a rectangle is base times height. And then we're going to look at the bottom. Remember, there's just the bottom, and it too is a rectangle. We can see it, that shape right there. So I could actually draw this in right here. This would come here, this would come here, and then this piece would go up here, so we get that three-dimensional shape, and we can see that's a rectangle, okay? And the base, so we just have one of those, and it's just base times height, so because it's a rectangle. And then we're just going to substitute and solve. 2 times, well, the base on this one is 4, and the height is this measure right here. And it said, okay, so here's the measure right here, sorry, it's 4 feet. The bottom, okay, so the bottom right here, here's the base right here, so it's 4 times the height, which is right here, which is 3. And then all we do is just solve. 4 times 4 is 16. 16 times 2, well, 6 times 2 is 12. Carry the 1. 2 times 1 is 2, plus 1 is 3. And 4 times 3 is 12. And we know we're adding all of these up, so we just add them up. 2 plus 2 is 4. 3 plus 1 is 4. And so that I know that that total lateral surface area is 44, and then our unit measure is feet, and then squared. Okay? And so that is the end of this lesson. And then in class, we'll do the even ones. Okay? So we'll do the odd ones during the review, the video. We will do the even ones in class. All right? I'll see you in class.
Bye.
And that is the end of this lesson in Mrs. Cox's classroom. If you are enjoying my videos, please like and subscribe. Thank you.